Hey everybody! Hey everybody! Let's start class. Now we're recording. We're doing some review. I know some of the hardest stuff that students have was dealing with this R of T and dealing with stuff like that. And since the line integral depends on it, I thought we'd cover some R of T and generating the equations and finding the endpoints and working with them. And tomorrow we will do setting up double and triple integrals. So I'll give you some time to work those out. Yeah, James's dad told me I shouldn't tease students or I shouldn't pick on students, and I just laughed because Mr. Blakely tells us, but Mr. Blakely, he like fake whines like he's pretending he's a student. What's more insulting than that? Calling your students whiners. I don't know. There's a lot more insulting than that. But the point is, he said I shouldn't insult students. And I'm like, motherfucker, you did it to me. I learned it from you. I did too. Mr. Blakely made me the bully that I am in class. Well, outside of class. I try not to do it in class. But at Starbucks, it's you're fair game.
Wow, if this is your low bullying in class, then I gotta wonder what outside the class looks like. Then
I'm not a bully in here. Who have I bullied?
I don't know. What about James? What about Benjamin?
How have I bullied James?
What about Lawrence?
Lawrence, you bully Lawrence all the time.
I bully Lawrence outside of class. I'm not bully, tease. Bully is the wrong word.
I'm sorry, playfully tease.
Like I'm not trying to take his lunch money and shit.
I don't know what I saw.
Although I should. He told me he's going to Hawaii in January, and I'm not going to Hawaii in January. So he got more lunch money than I got. So for those of you, if you've forgotten how to do this, what we're doing, I'll get you started on the first one. To find R of 0 or evaluate these to get the endpoints, you just plug in 0 for T. All right, so that's like those are the endpoints.
Wait, sine of 1? No.
You gotta love them sine of 1 and cosine of 1.
You just leave it as sine of 1.
Who said it was pretty? That's something else you got to get used to. A number doesn't have to be pretty to learn.
Yeah. I was like, oh, I got that too. I was like, sine squared 3. What the?
James, the class voted. They think it's a hard mode test.
I was like, what the hell?
James, the class voted while you were absent. They said you need a hard mode test for the final while they all get a regular one. That's being a bully.
Oh.
Just to point out the difference.
Like we
didn't
couldn't
really do that, James.
Regular behavior.
We didn't really do that, James.
Oh, if you actually did that, that'd be funny.
Yeah, that would be singling out students. That's how he gets fired.
I wouldn't get fired. I get reprimanded is the right word. Like, don't do this in the future.
A slap on the wrist.
No, it's not a slap on the wrist. It goes in your file and shit like that. So if there's repeat offenses, but you got to do some serious repeat offenses and not make amends. Like if I did that to James, I'd just have to give him an A, which is
So-
probably gonna what happens anyways. Let's be honest.
So the only way this
Well-
could actually be repeatable is having James again in your class.
Wait, what?
Well, the only way this is gonna happen again is if you have James again in your class.
No, I mean, like if I did something where I gave him a hard test and he ended up getting a B in the class and I put that on the transcripts, I'd have to go and in retro change it. Because that wouldn't be fair. The point, it was a joke. Let's just drop. Let's get off that.
We're very big fans of jokes, so that's why we like to accentuate them.
Brandon's over here trying to get me in trouble. I haven't signed his final paycheck. So that's some bold moves right there.
I've been bold all semester. What are you talking about? I was bold on computer science those 2 semesters as well. You know this.
Yeah.
I was in the 2 computer science classes. He was learning C++ as well.
I think I made some students worse by being in those classes because I was vocal and it encouraged students like Brandon to speak up. And now look at him mouthing off.
Yeah, it's gonna be hard to get used to Mrs. Harper's class when I can't be this vocal.
Yeah, she's a very different teacher.
Oh yeah.
Well, at least I'm not going anymore.
So hopefully you guys we're chugging along and done with these maybe by now. Let's see, sine of 0 is 0. 0 cosine of 0 is also 0, and e to the 0 is 1.
Thank you, Lawrence. Thank you, Lawrence, for not falling for the trap. The very obvious trap. Oh my gosh, don't use a calculator for e to the 0, please.
Well, there has been at least one test in this class where e to the 0 just turned into 0. And I don't know if it was an accident or it was not remembering that e to the 0 is 1. So I want to make sure like I can address that. All right, so if we plug in 1, this is delightful. Sine of 1, cosine of 1,
Something to 0 and it turns to 1.
e to the 1.
That's like my family saying like, why can't you divide by 0? Makes no sense.
Oh, no wonder I can just figure out what the percent is. There is nothing.
Except the Rax plays here.
Like 30 minutes trying to figure out what.
I still don't understand why they think they can divide by 0.
So your answers don't have to be pretty to be the answer. Keep that in mind. You're just used to getting problems that are tailored to have nice little pretty answers. And you saw from the last test that Mr. Jones made that not all questions have pretty answers.
Yesterday.
All right, let's take a look at that last one. What do we got going on here? I'm gonna write this out because I've got e to the 0 cosine of 0, and I've got e to the 0 sine of pi minus 0. I got a comment there. Oh, I only made it 2-dimensional. That's good. So what is that? E to the 0 is 1 and cosine 0 is 1. So that's 1. And then e to the 0 is 1 and then sine of pi is 0. We plug in 1, I got e to the 1 cosine of 1. Nope, I'm just jumping ship over here, just looking at what I had before. I've got e to the 3rd power, and I've got cosine of 3 pi over 2. And then here I've got e to the negative 4, sine of pi minus pi over 2. So this is e to the third power. Cosine of 3 pi over 2 is straight down.
Yeah.
And so that's a 0. And then I've got sine pi minus pi over 2 is sine of pi over 2. And we know that's a 1. So r of 1 is 0 e to the negative 4.
The -4. And I was saying, I didn't realize approximately the same value. You know, would it's been like, say, by a magnitude of error, or with magnitude, order of magnitude?
Please try not to make a mess, because the last time there was a mess in here, they found ants in here.
Scrambled there.
Yeah, please, if you're eating, be clean, because we're not supposed to eat in the classes.
Not. I'll do the sign.
Okay, that
All
doesn't
right, you
stop
guys
you
ready
from
for some more?
does it? Exactly my point. They have sides in there.
At least I gotta be.
All right, let's kick it up a notch. That was the easy part. Let's find the line integral and parameterize this region. Because figuring out what these lines are is the challenge. So I rewrote down the formula for you. If you like using formulas. And to maybe make sure we're all starting on the same page, I'll work with you on setting it up. So let's set this picture up and figure out what we're going to do. So I've got x equals -2 is over here. And I've got x equals 3 is over here. Y equals -1 would be right there. And y equals 0 is on the x-axis. So my triangle, or my not triangle, my rectangle that we're looking at is that rectangle right there.
I'm loving that pair of triangles you got.
So let's label them points. I'll start in the lower left. I'll call this A, B, C, and D going counterclockwise. So A is left 2 and down 1. That's -2, 1.
So it doesn't matter which order you go in, right? Like which direction you decide to like circumvent.
Yo, it very much matters. You need the region on the left. So we need to go counterclockwise.
Yes, actually, depending on which way you go, it could
Will change the signs, right?
it changes. I'm pretty sure it does just change the signs, right?
But,
Yeah, but that,
like,
if I change the sign on your bank account, you're gonna notice. Like signs matter. They're not trivial. I wrote this completely wrong.
Usually that's stated in.
like usually counterclockwise.
Yeah, counterclockwise is usually positive, clockwise is negative.
Yeah, so
But usually it's stated in the problem which way you're going.
Right.
like in the practice problem on. You know which ways to put it. It wasn't. I guess I was asking.
There was a
so
shitty one in the homework.
What?
But you had to look at it from the origin.
Oh yeah, not that one. I'm talking about on the practice final. There was a problem like this, but it wasn't stated.
In the final, I am very specific in saying counterclockwise. I will verify that right now. I'm looking at it. Let's see. Oh, that one, oh, shit, I didn't print out the final draft that has that on there. I'm pretty sure I stated it on there.
But this is one of those cases we don't even need a parameter.
Yeah, counterclockwise orientation listed. Let's see.
It's parameterizing between points.
I may not have put it on the Green's theorem one. You should be going counterclockwise because you need the.
We just use green theorem, like.
So for Green's theorem, the reason why we want to go, the idea for Green's theorem, remember we're doing F dot dr goes to dg dx minus df dy as a surface integral. So if we're doing this surface integral, we have to enclose the surface. And to enclose the surface needs to be the left of the path of that you're taking. So I'll make, let's write that. Surface must be left of the path. So if I'm walking counterclockwise, the surface is to the left.
That means the the circulation is going to kind of focus it inward rather than outward. It's just a difference between whether you have counterclockwise circulation or clockwise.
Right, okay. Walking on the wall versus the wall walking around you.
Isn't it just being thrown at the wall then?
Get it? It just means like if you're on the path, if you're anywhere standing on it, look to your left, and that's where the surface is.
If you look to your right,
If you're on there, like you say, if you're walking along it, you're facing the direction of travel, like you look to your left and there's the surface. That makes more sense.
Yeah, if you're on the blue path, if you walk counterclockwise, the triangle is within to your left.
If you were to walk the other way, then it would be to your right. Instead of to your left.
Yes, and you want it on your left.
You have to be standing.
English teacher.
I'm supposed to use the R.
I think C to D and D to A are probably the hardest lines on this for people. Because it's easy to put the points in the wrong order. We liked looking at things from left to right and up to down, but along C to D, along the top and along the left side, we are not going left to right. We are not going down to up. So keep that in mind.
Yeah, I see others. Take those for a second. I'm doing this wrong. Just parameterizing. You're just finding, you're just making vectors. I'm so dumb. I did it wrong. Yeah, yeah, we're not doing the whole problem. It's just a dumb poo-poo headed. We're just practicing.
Yeah, we're not doing the whole problem. I didn't give you a function. We're just setting up the, because the integrating isn't the hard part.
It is.
So if you got 5t minus 2 and -1 for a to b, you're doing good.
There's a lot. It's not like the last test. You can't have it repeated as your answer.
Let's see if this pink is obnoxious.
Was already blinding in the. Did I write down my values wrong? I swear that was y equals 0.
Yeah, it's like, yeah.
Get that shape. You get that shape at all out there. What's going on? So long. There's these 2 points. There's only 2 points. This point and this one.
Yeah,
Or did those points have?
it's coming from enclosing the square using these 4 bounding lines.
Oh, those are lines. No. I thought those were point words.
Well, oh yeah,
I would not even fuck up.
yeah, because he erased them, but those are lines enclosing the rectangle.
Like when I first off memory, I wrote it. I wrote it backwards.
Wait, what did you write backwards?
Brainstorm. Because like when you're doing the the test, the conservative field test,
Mhm.
you do like do df, dy equals dx, dg, dx.
Yeah.
So like that order got that.
Oh, you got that one.
That's just, don't memorize Green's theorem or the conservative test like that. I'm pretty sure I didn't tell you to do df dy equals dg dx. I'm pretty sure I told in the lecture, if you look at it, it's dg dx equals df dy. You might have changed the order on your own, but I gave it to you in order that might helps relate them.
Yeah.
I think that was on you, because I even remember him saying during class to not remember it, remember it in terms of Green's theorem rather than the conservative field test.
All right, so I've got the first three lines up. Working on D to A now.
Which one's which? There's two different ones. I didn't know that. Are they different? Isn't there a different one? I'm gonna get this wrong. I can't. I don't know which one's which. Every time I see this, like all the people that are, I see like 20 different versions of this. What the one would be over DY? Where did that one go? How do I know the difference? Well, it's nice because divergence has the word diverged in it, in the name.
Oh, yeah, actually, I do remember.
No, but how is this
Not only
divergent?
does divergence have the word diverge in it, it's got DV, DIV, DV is your triple,
That's not
is
what I'm
your
talking about.
integral.
Because I saw one where like,
So these are the four line or the four RFTs you should be getting. And I want to point out something that you can use as a check. You shouldn't jump to this in case you misremember it, but you should use it as a check.
Yeah.
Now, along A to B, what is staying constant if we look at the picture?
Is this the only one that there's why?
Y is staying constant. And notice along A to B, Y is constant. It's the same constant. So along A to B, that was the line Y equals -1. And sure as shit, we got Y equals -1 in our vector. Along B to C, X equaled 3. And sure as hell, X equals 3 in my vector. So if you do not have a change in if it's a vertical line or a horizontal line, one of your components should be a constant, should not have a T in it.
This is just one example.
Along C to D, Y equals 0. And we got Y equals 0 there. And along D to A, X equaled -2. And we got X equals -2 here. So the line that we have is really part of the thing when it's a horizontal or vertical line. And you can use that if you set up when you're setting up your R of T and you don't remember this formula well up here, if you do the formula and you get something other than what you should be getting when you work it out, you'll know you got your formula wrong. So like if I had the wrong formula and if I got like -2 here, I know I did the formula wrong up top or something's off. So use it as a check. Don't jump to it because you still can easily fuck up the other component. So just use it as a check.
Is it just all the zeros?
Pretty much, yeah. All there's like a couple like random like the equation to parameterize stuff. Like with all these numbers, it's like I mean, random shit. I don't even have time to look at my notes.
Yeah, I did this in, South Daisy, but they're trying to get work done.
All right, you guys ready for another?
Let me think again.
Who's all the same?
Well, is that it? Thank you. I didn't know what to call it.
What did you call it?
It just says speed nonsense, because I didn't know, like,
Oh, you mean like potential function? Yeah.
no, it's just like, oh, it's the fact that I didn't like me, I didn't know why, or like.
All right, so now we're gonna get a triangle. We're gonna do y equals 3 and x equals 0. Give you a second to write it down.
Why? Yeah.
Y equals 3,
Oh,
x
yeah, y
equals 0, and y equals 3x. So
So the actual triangle, not a take rectangle triangle.
those are the 3 lines. So it's just making this triangle right here. And again, you don't have to start in the lower left, but I like to. So A is 0, 0, and C is pretty easy. That's 0, 3. B, if you're not certain what it is, this is the line y equals 3x. This is the line y equals 3. Set them equal to each other. And solve for x to find out what the x component is. So we get x equals 1. And that makes B 1, 3. And remember, we got to go counterclockwise to keep the surface on the left. Wonder if yellow will show up. Nope.
If you can't see it from your angle, yeah, this.
Right.
We might be able to see it.
So this pin set I've got with dry erase markers has 3 pins. And under the camera, it looks like the middle one's easier to notice is different. The 2 on the ends don't look that different, but they are. I'm like, why do you have 3 colors that are so close in shade?
I can't tell the difference.
So let's keep going.
Always bringing for one person smart. 1, 3, 0, 3 first.
Chugging along. That color's not showing up well. I'm going to change to a darker color.
Yeah. Oh, just adding that. If you were just, if it's technicality, if you start with from AB to BC to CA, should be able to go back to the final point. But I don't know if it actually probably well.
Is something wrong?
No.
Actually,
Kind of curiosity question. That's all.
so right now, just practice with doing it.
Just
That's all.
Yeah, no, I see that. Good 46. Yeah, it's a very interesting. Very well, sure, it's definitely not part of the problem. No, I know, but I know, I get your point. I definitely get your point.
It's great to learn. Yeah.
No, I definitely get your point.
I work on my project though. You got it. I got a lot done.
Oh, because this is like, repetitive process. That's your question.
We're just gonna talk about it.
So where we were using these, we were plugging these into line integrals. And so when you plug them in, you're replacing all the X's with your X components, all your Y's with your Y components. Be patient, go slowly, don't rush it, because there might be some algebra that you got to do. Like if we have Y squared along that bottom line, I've got 3 minus 3t squared. Make sure you're not jumping the gun. This does not equal 9 minus 9t squared. I've seen this. People race through it and do it wrong. So even if you need to, like on a piece of scratch paper off to the side, write out what that means. Don't race through the algebra. Don't be upset when you lose points on shit you've known how to do for several years.
I know you guys. I see you're saying it works out for this one.
So don't rush it.
You get a 6.
I think it's just if I had to put my 2 cents in, it would be because of the way the vector does set up. Instead of being set up in a way so that
You made a little deliberate
did it make it out cheap?
mistake right there.
What did I do?
3 times 3 is, wait.
Oh no, you're right.
Yeah, I did.
Oh,
I totally
that's
did.
not-
Oh yeah. Oh okay.
I'm all over here rushing it myself, just going brain dead.
Ooh.
Fucking fail. F. F.
My thinking is that it's the way that it
You say
I was testing you.
Yeah. Thanks.
All right, let's set up one more, at least look at the triangle setup. It's another triangle. We've
For
done this.
tomorrow,
for-
can you- where is it? Where is
I think it's also
for tomorrow's class, can you go over like
it might
spherical as well, like maybe an emphasis on that, because on the
Yeah,
homework-
we are.
on
I'm
the
gonna hit
homework section-
tomorrow. I'm hitting the
They
stuff that affects the flux and divergence.
Okay, they didn't have that many spherical examples, they mainly had cylindrical on the homework set. There's like 2 problems with spherical, basically.
Yeah, we will definitely hit on it tomorrow. And we can also touch on them in evening Starbucks if we'd like. Don't forget, if you are interested in Starbucks, I will be there from 6 to 10 if anybody stays till 10. Last time people left at 9, and that's when I left. But I'll be there at 6 p.m.
I'm also holding my last SI hours before the final today from 1 to 3 for anybody who's interested. So something I thought about is that if you put the bounds for T in and then added them together, maybe you get what you're expected answer. No, you already. It's just a thought.
So I've got X equals -1 there, Y equals 5 here. 2X plus 1 starts here.
But it's good to think that way, you know, because they're like these types of things. It's good to think that way. Even if it doesn't lead you anywhere.
So one of these points is pretty easy. The upper left corner is -1, 5. This is the line X equals -1, and this is the line Y equals 2X plus 1. I can find the Y-intercept by where these two intersect each other, just by you putting these two lines together. At y equals 2x plus 1, we have x equals -1, so y equals 2 times -1 plus 1 gets me -1, which is what it looks like pictorially, but sometimes picture doesn't do it the right justice. It's better to do the equation and verify. On the top line, we've got y equals 5, and we're still doing 2x plus 1. Now we'll set they're both equal to y, so we'll set those equal to each other. And I get x equals 2, so this is the point 2 comma 5. And put this up here. I'm going to try to go through these pretty quickly. See if I can race through them at least so you can get a picture up.
No rush.
Because at least this first line is going to be the most challenging one, the diagonal.
But Mr. Jones, you said to not rush through these problems. Why are you rushing?
You should. I'm doing it for time constraints because we've got other things to do tomorrow for review. Don't get sassy with me, boy.
Oh, I wasn't the first one to sass.
Racist comes out.
I'm getting 3t minus 1 and 6t minus 1.
Oh, come on, I'm not racist. I'm fair to all. I'll ruin all your life.
I'm completely racist to everyone.
I'll be rude. I'll be sarcastically rude to all of you.
Racist against the human race. That's fair.
So anti-humanitarian.
Yeah, just so racist. What about grandpa?
Oh man. Family who said, I want to be a racist when I grow up.
Look at this. I'm going to get them all done. Go, 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 go.
You see, when you speed across the highway, you do indeed go faster. Much too popular.
On average.
Well, as my sister would say, no cop, no stop.
Bam. Before 9 o'clock. Like a master. The setups we've done today are more difficult than the one on the final.
That day was crazy.
But you said the setups we've done now are more difficult than the ones we've done on the final.
This is a pretty difficult set. There's a lot of ways to fuck this up. It's easier than this problem for the line integral one.
And you're probably doing this using green theorem anyways.
Well, the Green's theorem one is do both ways, do the line integral and the Green's theorem. So they need to be able to do both.
Oh, okay. If I had to choose, I definitely do green theorem with this one. I don't want to do set up 3 separate ones.
Well, that's too bad, because that's, line integral is on the test. Got to make sure you
Well, I
know
was
how to
saying
do
if I
line
had-
integrals. That's in this chapter.
If I had to
Either I
choose,
do a
what if I
separate
used
problem
to-
on them, or I put it in the Green's theorem test. Be happy that I don't make you do the flux and divergence one, the divergence test on both sides, where you got to do all the surfaces. That's the pain in the ass.
Oh, gosh, yeah.
I will see you guys tomorrow or tonight. I assume someone's coming tonight, so I will see you there.
Well,